Okay, we're moving on to the third last topic in this course, not that I'm counting obviously. Moving on to control flow today. It's a notoriously difficult topic to explain. I've found it difficult in the past, but I've had a bit of practice making other videos and stuff, so hopefully I'll be able to explain it okay. Quite a short video actually, it's probably quite simple as well at the end of it, so just, yeah, bear with me. So let's just define what flow control is. This is quite a key concept, and it's sort of obvious really, but it's quite difficult to define. So program flow is the order the code is executed in, and it's completely controlled, it's manipulated by the programmer, although choices made by the person using the program will influence the flow. So it is literally flow. It's easy to visualize it as sort of water flowing, yeah, in a stream. It's the execution path going through the program, and like I said, it's quite difficult to explain. Hopefully it'll make sense in a minute. So I like to think of it, and I don't know if everyone uses this sort of phrase, but I like to think of it as there being three main building blocks of code that control how the program flows. And the first of which, and the simplest, is sequence. And a sequence block, here each line is directly executed after the previous line. So it really works in sequence. Once one line finishes being executed, the next one gets executed, etc. It's a bit like how the interpretation translation happens, as we looked at in the previous video. So what it means is, it means that every line between the start and the end, so this is like an example of sequence. The first line in this sequence block precedes the next line being executed. It just goes line by line really, and we can represent it by a flowchart, as simply like this, just where it passes through each process block line by line in a sequence. And if we I guess we could represent it in pseudocode if you wanted. Like I say, I talked about pseudocode a couple of videos ago, and I mentioned it's not really that important how you do pseudocode. There's a few things I like to do. So we could do a really simple one, number equals 10. That's what I've always used for equals in pseudocode. Doesn't really matter, you could do it as an equals or whatever. And we could do add 5 to num, and then we could do output num, and then we'd hopefully get, if we converted this to program code, we would get 15. So that's just a bit of a pseudocode representation. Yeah, if we move on to looking at the second block, slightly harder to understand, but again, I'm sure you would have used this. If you've done controlled assessments or programmed in high-level programming languages, you should have used this really. You may not have thought of the theory behind it necessarily, but you should really have used these blocks. The second one is selection, and here the program's flow is determined by if and case statements, and they're called conditional statements because a condition is met, and depending on the conditions, the flow path is selected, meaning that not every line in the code is executed. So I mentioned before that in sequence every line is executed. In selection, not every line is executed. Some lines are chosen to be executed. So if we first look at a flowchart representation, I apologise for white background, but it doesn't really matter necessarily. So if you think of it as flow, and please bear with me, my graphics tablet, if we have a flow here, if you just imagine this is the way it's being executed, oh, that's absolutely terrible. You can see here that that's the path of the execution, and what that means is that the program's been ran, and it means that the selection first, the first selection is being it's going to be false as opposed to true. So this bit never gets executed. This bit never gets executed. The lines after this bit don't get executed because the choice has been taken elsewhere. So we get false and we get false again, meaning that the other true bit also isn't executed. So it's really, I like to think of it as the code weaving its way, or the execution weaving its way through the code. That's just how I like to visualize it. And then if we've got our example here. Test equals 5, if test equals 5. So this is an example of if statement, this is a case statement. If test equals 5, print test pass. So this bit runs because that's correct, that's true. But this bit never gets to run because it doesn't even look that far. It will skip this bit out. It won't execute this bit because it knows that it's not right. There's no point in it. It's already, the selection's already occurred, and we know that it equals 5, so we print test pass. Test fail will never get printed. Hopefully that makes sense. Again, we could represent this in pseudocode. Be very similar to before, I guess. If I just do an example here. Okay, so I struggled to think of an example. I was Facebook, they do this age limit, don't they? So we could do age, and we could do it another way, is 12, and we do if age is less than 13, deny access or something, I don't know, deny access. So if we're doing like a website, you've got to be 13 to join, and then else will do else allow access. That's a very simple pseudocode. We talked about pseudocode before. It's just a very sort of basic plan of how you're going to do code. So the final building block is iteration. And iteration just means repeating or looping. We use looping a lot in computer science. And loop statements repeat until a condition is met. So there's two main types of loop, while and for. For is really a set amount of times, and while is more, could be infinite really. You want infinite loops are like the worst thing for a programmer because they just crash the program. But while loops, they're sort of more open. They keep repeating until the decision's met, basically, until the condition's met, I should say. And I should say that this this line, the way it's denoted, is through this a backwards arrow on a flowchart, and this will just keep looping and looping and looping until the condition is met and the program ends. And this is like an example of it, a password program. Basically, it keeps looping. We've got a while loop here. If it was a for loop, it wouldn't really work because it means after you try the password wrong a couple of times, it will let you in. A while loop will keep doing it until the password is entered correctly, and then you'll be allowed access to the program. So that's today's video done. Quite simple really, I hope. We're looking at slightly more on algorithms next, such as data types and booleans and constants. Lots of good stuff. So hopefully you'll join me for that video, and yeah, I'll see you then.